Hello, good afternoon, everyone. Can I assume everyone is done with the QR code? Can you guys hear me? Yep. Just in case someone didn't actually scan the QR code, just send the link in the chat, which you can find already in the chat already. So I'm just gonna stop share and let's just gonna get started for this tutorial, all right? So you've already downloaded tutorial sheet. You will find 3 exercises for today. Let's just change the order of the exercises a little bit. So we can do exercise 1 first and then 3. At last, we are gonna do exercise 2, just because basically exercise 1 and 3 is gonna give you some basic idea how we can implement transactions in PostgreSQL. So you might want to see the effects first so that you can have like a concrete or solid understanding of how transaction goes. So you can do like this kind of exercise, which is more like abstract. And also this is the kind of exercise that you can find in the final exam as well. So you'd better be familiar with this kind of stuff. All right. So let's first go through exercise 1, transaction supporting SQL. Basically, this one is also related to the statements that you can find from week 5. So if you've already did any changes to the week 5 stuff, you might want to use the file from week 5 and create tables again, so we can be on the same page and we'll get the same solution to all these questions. All right. So the transaction concept is reflected in several parts of SQL. In SQL, you can group several statements into a transaction. So basically, this is what transaction means. A transaction is going to execute all the statements within that at the same time, regardless of their orders. And they can be done with commit, or they can roll back with a command of rollback. Many SQL dialects with SQL Server, also PostgreSQL, use an explicit begin transaction or begin command. That means begin transaction equals begin. That means if you change the beginning here and replace that with begin transaction, it'll be doing the same. To start a transaction is requested to finish successfully using command or aborted using rollback. So if you commit a transaction, all the statements within that transaction will be done automatically at the same time. And also if you roll back, the legal state of the whole transaction will be go back to where the transaction was not done before. And question 8, try out the following small script in PostgreSQL that tries to add 3 new lecture theaters in the new law building to our university database using the university schema from the previous tutorials, which is this. So if you already got all these the tables, you will be finding all these as in this schema. If you do refresh, you will find all the tables being set up as we previously already did. And you might want to also get rid of the scripts in here, so you can start with this transaction. All right. So what classrooms starting with ls are shown before and after the rollback keyword? So this is the question in question A. All right, we're gonna start by copying paste begin transaction and the 3, sorry, why I can't actually copy and paste those. All right, so begin transaction, insert statement, 3 of them. You'll need to copy and paste all those. You can just watch what I'm doing here, or you might want to do on your end as well. It doesn't actually matter because it's a very small task for you guys to see what's going on within a transaction and what the effects are after that. So begin, insert into, I guess all those are all good to go. So what is that? Classroom Oh, sorry, I didn't actually execute the function previously. Yep. So you might need to import the file again so that you can have all the tables as previously we did. Oops, sorry, you're just because we've already begun the transaction, so you better need to. And we're going to import all the scripts from previously week 5 tutorial and execute that. You will have all the tables set up again. So now you are in a better position to get started with this transaction. Oops. This I'll just be copy and pasting those that will suffice, I suppose. Yep. So here you will be able to insert into the database as we have previously did. So query return is successful, which means these 3 statements has been executed. And next we're going to check what we have so far, which means we're going to see what are the classrooms with the classroom ID that starts with LS, all right, which are the 3 classrooms we've just inserted, like in here. So what you are expecting to see is the one we've already executed. So this is the reason why you can see like 3 tuples in the resulting table. So we are checking what we have so far within that transaction. All right. So we haven't committed. That means the transaction is not done yet. And we are going to roll back, which means we're going back to the state where we didn't actually have those 3 entries. So if we do roll back, you'll see return successfully. That means we didn't do the transaction at all. And we are going to select everything from the database and see which classrooms has this classroom ID that starts with LS. All right, as expected, we don't have them. Just because we rolled back, that means the transaction that starts with begin to roll back is not done at all. All right, question B, now try the same script but with rollback statement replaced with commit. So this time we do want to insert into the database with these 3 statements and see what's going to happen. You may want to copy and paste all those again and insert the entries. And where is the rollback? Yep. So you'll need to change this rollback to commit. It doesn't actually matter if it's lowercase or uppercase. So commit that. And you're going to see 3 tuples as we selected from the database. These are the 3 we've just inserted in here. So this is result from this statement. So we can actually see all these. If you are not too sure about that, you may want to delete all these and execute this statement alone. We'll obviously see these again, which means the statement has inserted into our database successfully. And these records has been valid in our database. All right, so this is exercise 1. Basically, what you will need to know from here, the takeaway from here is that you'll distinguish between commit and rollback, and you should know what's happening within a transaction and what is going to happen if you roll back or if you commit. Okay, so question, exercise 3. Transaction isolation experiment. So isolation is a very tricky and a very important property of a transaction, which means the transaction is isolated if it is still running and it's not done yet. And if 2 transactions are being executed at the same time, they should not see the effect of each other at all. So in this exercise, we're going to give you some intuition of transaction management you will begin by opening page.admin in two windows. All right, the way we can go about doing that is you might want to create a new query tool. And if we label that with window 1, and this is our window 2, all right? So that we can do the experiment as instructed in this table. So they execute the following two transactions line by line as seen in the following figure. Press execute after each line and write down the results of the select count statements. So this helps you to see what is actually being done within a transaction and after that. Now how the two transactions can see each other's work with the concurrency control. All right. So begin transaction in window 1 and execute that. And in window 2, execute this. So you might find it a little bit different. Both of them are trying to begin a transaction, but in window 2, we set the transaction isolation level to be serializable. So this is a command that can set different levels of the transactions isolation level. It can be serializable, or sometimes it's like read committed or read uncommitted. And also there are some like other options as well, but I don't think you'll be aware of those. All right. So the default option, which means in window 1, we didn't actually set that, right? That means this goes with the default option, which is read committed. So what it basically means is that this transaction is going to read all the other transactions that has been committed. Otherwise, this transaction cannot see. And in here, serializable is a little bit more stricter. Strict. Is that the correct spelling? I guess so. Stricter. No, stricter. That means serializable doesn't actually issue exclusive lock. It doesn't issue shared lock at all, which means if this transaction is accessing some kind of like data, other transactions can't actually read at all. All right. But with the default one, which is read committed, other transactions can read the data that has been accessed by this window. So this is a default one. All right. Window 1, select count from student. You might want to replace all the scripts with this one. So count 6, which means we have 6 students recorded in our database. We might want to replace the question mark with our solution in here. So that'll be 6 in here. All right. So in window 2, if we do actually the same, just because we didn't actually do anything to the database as of yet, so you will actually be seeing the same as we can assume. So we obviously see 2, 6 in here. Next, insert into student values. Insert test values. We might want to look at the schema and see what the attributes are, so we can insert. So student ID, name, password, address. All right. This means within the transaction 1, we are going to add one more student. I just presume student ID is an integer with a 1, 2, 3. I guess it should suffice. And name, I'll just use my name. Password YYDS, and address. Sorry. And to the point. I guess this will be successfully executed. Yep. And next, we're going to execute within transaction 1 again. So select count from student. Guess what it is? Is it going to be 6 or 7? Right? Just because this is within the same transaction, is it going to see the result of the previous statements within that transaction? Yep. 7. That's right. That means this has been updated to 7, even though we haven't committed yet. Just because they are within the same transaction, that'll be 7. And what should be the number of the count as in window 2? Seems like I don't need to copy those at all. It's the same execution. All right. So what should this be? 6. Very good. Why? Just because we have a mechanism that is concurrency control, which means if 2 transactions are being executed interleaved in an interleaved manner, they can't actually see the effect of each other. If they are not actually committed as of yet. All right. So this is 6 again. And next, we're going to commit in transaction 1. All right. Return it successfully and select in transaction 1 again. What is it going to be? 7, as expected. Why? We have committed everything. So transaction 1 can actually see what itself has done. And next, in window 2, we're going to select from student. Obviously, it's the same statement. Guess what we can see here? Are we going to see 6 or 7 this time? 7. Nice guess, but wrong. You're going to see 6. All right, so execute it. 6. Why? Even though transaction 1 has been executed, just because of concurrency control, they can't actually see the effect of each other instantly. They will be seeing each other's effect once they are both done. All right, that means if you commit in transaction 2 as well, you will be able to see all the effects from both transactions this time. So this is the reason why you can see 7 here, as we can expect. So that'll be the correct one for this solution. All right. I assume everyone can understand what I'm doing here. And so the takeaway from here is that the transactions can't actually see the effects of each other if they are set to be on an isolation level that is serializable or read committed. Otherwise, if you set it to be like read uncommitted, this means they should be able to see other transactions effect even if they are not done. What does it mean? It means they should see each other's effect instantly as they are executed in an interleaved manner. But in PostgreSQL, there is a very tricky part of that. So read committed equals read uncommitted. I guess this is a different feature in page admin 4 as compared to other SQL platform, as in MySQL or Oracle. but in PostgreSQL, read uncommitted is treated exactly the same as read committed. Okay, I guess we are done for this question. And exercise 2, this is going to be pretty similar to your final exam question. So I guess you guys want to spend like a little bit more time on that. So can you guys please go through exercise 2 respectively, and then we can go back and discuss all the questions within this exercise, all right? So I guess 10 minutes will be enough, okay? I will have you guys come back in about 10 minutes. That'll be 5:35, okay? So work on test 2 in the next 10 minutes. Is everyone done? Has anyone completed all these questions? All right, I guess we can get started. So given the following relation, offerings, 4 attributes, consider the following hypothetical interleaved execution of 2 transactions, T1 and T2, in a DBMS where concurrency control, such as locking, is not done. You'll need to note this feature just because it says not done. That means the transactions can see each other's work instantly as the execution of each statement. That is, each statement is executed as is submitted using the most up-to-date values of the database contents. So this is just basically what the concurrency control is not done means. So T1, execute select from offerings where lecture ID equals 4711, which corresponds to both of these tuples, which means T1 is going to see all the tuples in this database. So question A, the value returned by this select statement and the final value of database. So basically first, what you can see from T1 is both tuples. And second, select ER into YR. So the colon YR means this is a variable and we want to insert the value into this variable so that if you want to get that value later on, you will just refer to this variable again. You don't actually need to select again. From offerings where US code equals COMP9138, which corresponds to first tuple. So what is this one seeing here is the year in the first tuple, which is 2021, 2021. And what is the final value of the database after the 2 updates in here? Anyone? What is your final solution? Any hints? Guys? No? So what is T1 doing here is that this is going to set the year by adding 1 to the first tuple. So by executing this statement, this 2021 is going to be 2022, right? Thank you for your solution in the chat. But let's see what's going on here. So after this execution, the year is going to be 2022, all right? And after T2, which is this update, this is going to set the year by adding YR by 2. What does this mean? What is YR then? YR is the value that we have created from this select clause. That is 2021, right? And we are going to add that up by 2. That means 2021 add 2, that equals 2023. And this value is going to override this value, which means this 2022 is not going to be appear as the final result of the database. So 2023 will override 2022. So final value is 2023. Okay, so this is basically because the concurrence control is not done. All right, so T2 will actually see the result of T1, and this is going to override this setting. Yeah. Okay, so question B, whether the execution produces any update anomalies. Anyone? Is it going to produce any anomalies? What is an update anomaly, guys? If you don't actually know what is an anomaly, you might want to go back to the lecture slides where you can find on page 38. Oh, I don't know why it's 38. This is like 36 here. Why the next page? 38. All right. Anyway, we have like 3 possible anomalies, like dirty reads, unrepeatable reads, and lost updates. So pretty obvious. This is going to be lost updates. Why? Because we are overriding uncommitted data. This corresponds to what we can see here. So T1 has updated the year to 2022, but this 2022 is going to be overwritten by this 2023. So does it actually matter what we have done in T1? No, there's actually no effect from T1 at all. All right. No matter what you update from here, the final result is going to be go like with the T2 update, which is 2023. Even if you update it to like 2021, add it up by 10, you'll get a 2031. Whatever you've done here, the final result will just remain the same, which is 2023. Okay. So next question, question C, whether the execution is conflict serializable or not. Any suggestions how we go about doing this question? Or you might just want to pop up with your solution in the chat if you already have a solution. Is it going to be conflict serializable or not conflict serializable? To determine if it's conflict serializable, firstly, you will need to understand what the question is asking. All right. So basically, in a plain language, this question is asking, is this interleaved interleaved what is interleaved? There's no happening there. All right. Is this interleaved execution gonna produce the same result as any sequence of executing transactions 1 by 1. All right. So you'll need to know what the question is asking you. Like for this question, we only have like 2 transactions. So basically this question is asking you, is the result going to be the same as we execute T1 first or T2 first? So either way, we are going to determine what is going to be the result. Okay. So what if we execute T1 first? We are going to select everything from there and update the value from 2021 to 2022. All right. Up to here, we have executed T1. And then T2, we're going to select the year into YR, and this time YR is 2022. Makes sense? And then we are going to update the year by adding up 2. This means it's going to be 2024. all right? What if we execute T2 first? So select year into YR, which means this time YR is also 2021, and execute T2. This is going to be 2023. And then T1. Select everything from here and update. This time 2023 is going to be added by 1. That'll be 2024 again. So from here you can see that either we execute T1 first or T2 first. You'll eventually get 2024. However, the interleaved execution as in here will actually produce 2023, which means they are not the same. So conclusion is that not conflict serializable. If they can be regarded as conflict serializable, they will actually produce the same result as either of them. Okay. What if executing T1 first is going to get you 2023? The interleaved execution is going to be conflict serializable, and you are going to give a serializable execution that is T1 to T2. However, we don't have them. That means the solution is only not conflict serializable. This is going to give you a problem. Like, what if we have 3 or more transactions? Like we have T1, T2, and T3. How are you going to go about that? You will need to actually determine, is the execution, the interleaved execution, going to be the same as 123 or 132 or 213, 231, 321, no, 312, 321. Are we going to all this? Are we going to do all the same? Obviously no. Just because it's very time consuming, right? So the best way of doing this kind of exercise is to assign a notation as R or W, that means read or write respectively. If you refer to the first tuple as A and the second tuple is referred to as B. So each transaction, if one of the transactions is accessing one of the tuples, this is going to return a notation as what you've learned from the lecture as in here. So select from offerings where lecture ID equals 4711, which means we are accessing both of these tuples, right? So the correct notation is that R1, A, and R1, B. This means we are going to read tuple A and tuple B in transaction 1. And next, transaction 2, select year from offerings. This means in transaction 2, we're going to read from tuple A, right? So basically, the reason why we're using R here is that we're only going to select something from the database. We are not doing any changes to it. Otherwise, like in these statements, by using update, we are trying to write into the database, right? So what is the notation for this execution? Anyone, any ideas? How do we use this kind of notation for this statement? W1A, very good. However, not right. You will have to be reading from 1 first and then write. Why? Does anybody see why? Are we just going to write into A regardless of what A is? Are we going to read from A first and then build on that? We are going to add numbers on that. That means you're going to select the year from tuple A and update again, okay? If the statement is like this, select the year, set year equals 23. This is going to be a right W, right? However, here you're going to add the year up by 1, which means you can actually see what the year is before. And based on that, you can do the right. So you will need to do read first and then W, right? So this is the correct notation of this statement. So next one, what is the notation for this one? W2A, very good. So this time we are not going to read anything from the database just because this value is from YR, which means this has been read and this is a variable. And we are just gonna set the year regardless of what was in the database. So it is going to be a W, enter, and A. All right. So these will be the correct notation of these. And next, we are going to, if you write all these, the sequence of the execution as in one line, you will be able to identify if you've got any conflict pairs. So let's see how we can do that. The R1, okay, so basically copy and paste all these. R1, B, R2A, R1, A, W1, A, W2, A. So, and the question left for us is that, is there any conflict pairs? Make sense, everyone? How do we determine if there is a conflict pair? What is a conflict pair? So we got 3 conditions. First, they should come from different transactions. Transactions, okay. Second, they should be accessing the same data. 3, one of them has to be W or 2W. Okay. So this is going to be how we can determine if there is any conflict pairs. All right, thank you for showing up what the conflict is in the chat. So R1A and W2A is a conflict pair, like in here. So we have R1A here, right? So this, and also W2A, this is going to form a conflict pair, right? Why? Because they are from different transactions, as is noted by the numbering there. They are accessing the same data because they are both A, and then one of them has to be W, as in here, W, right? So from this transaction, from this conflict pair, if it is conflict serializable, you will need to put T1 before T2. All right. Is there any other conflict pairs? Is there any other? I think yes. Because basically you'll have W1A there. What we are looking for is either any R2A so that we can form a conflict pair. Obviously we have, like in here, R2A and W1A. This is going to give you another conflicted pair as well. But the conclusion from this conflict pair is going to be very different to the previous one. So you're going to see 2 first. So T2 should be executed before T1. And regardless of any other conflict pairs, if there is any, these 2 conflict pairs is going to form a cycle. Right? Is there any cycles? Yes. So we have from T1 to T2 and also from T2 to T1. If there is any cycle, that means the conclusion is going to be not conflict serializable. Okay. So this is the second way of doing this kind of question. What if a cyclic that will be conflict serializable? All right. I think this is the correct way of doing this question. Another question that I want to ask you guys is that how many conflict pairs in this question? What if you are going to list every conflict pair? How many of them are there? Like in here. How many conflict pairs as you can identify from the execution of this? Anyone? I guess there are 4, right? 3 or 4? I think there are 4. Like we've already got 2 in here, right? And another 2. So we have R1, R2A, right? And we have another R1A here. So this is this R1A is different to this R1A. So we have 2 R1As. They can both be a conflict pair together with this W2A. And also the left one is W1A and W2A. This is going to be another conflict pair as well, right? So we have 4 conflict pairs in this execution. Anyway, by using only 2 conflict pairs, we've already determined this is not conflict serializable. So a normal question that has always been asked in the final exam will be like, is it conflict serializable? If not, why? If it is, give a serialized schedule. So this schedule means you're going to specify, is it going to be T2 and T1 or T2 or T2 and T1, all right? So this is going to be the question that you will get in the final exam, as I can assume. All right, I guess that's it for today. If no other questions about this tutorial, basic exercise 2, I guess that's the end of today. I will see you next week. So if you do have any other questions regarding this or any questions regarding the quiz that we had in the previous week, you may want to remain in the room and talk to me, I guess. So I will just stop share the screen and also stop recording. All right. Thank you guys for coming. So if anyone has any questions, I'll just put you in a breakout room and we may want to discuss the questions there. All right. Or just you may want to remain in the main room as well.